Good morning, my dear students of first secondary. Today we are going to study a new geometry lesson. This lesson is called Applications on Similarity in the Circle. Let's start. Geometry Lesson 4. Applications of Similarity in the Circle. Prepared by Mr. George El-Maadi. One of the beautiful lessons in geometry and one of the easy lesson of geometry. Applications of Similarity in the Circle. Well-known problem. If AB and CD are two chords in a circle, AB and CD are two chords in a circle, intersect at the point E. Okay? So, EA multiplied by EB equals EC multiplied by ED. Okay? Let's explain it together. Here, AB and CD are two chords intersect at the point E. So you are going to start from the point E. So EA multiplied by EB, this is equals to ED multiplied by EC. So if you have two intersected chords AB and CD, the two chords intersect at the point E, so AE multiplied by EB equals CE multiplied by ED. Okay? Here another one. If AB and CD are two chords in a circle where AB ray intersect CD ray in the point E, then EA times EB equals EC times ED. Okay? Here you can see that the two chords AB, here this is the chord AB and the chord CD, they intersect outside the circle. In the first case, the two chords intersect at the point E inside the circle. But in this case, the two chords AB and CD intersect at the point E, which lies outside the circle. So if the two chords intersect outside the circle, okay, so you will start again from the point of intersection of the two chords. So here from E to the beginning of the chord, which is EB, multiplied by E to the end of the chord, which is EA. So again, from the point of intersection to the beginning to the start point of the chord, which is B, so EB multiplied by from E to the end point of the chord, which is A, this is equals to ED multiplied by EC. Okay? So again, EB multiplied by EA will be equals to ED multiplied by DC. And the last case, here if M is a point outside the circle and MC touches the circle at C, MB intersects at A and B. Here the letters are different. I will fix it. Okay. Here M is a point outside the circle. So this point is M. Okay. Outside the circle. MC touches the circle, which means that MC is a tangent. In this case, MC touches the circle, which means that MC is a tangent. And MB intersects the circle. This is MB intersects the circle at the 2 points A and B. Okay, so here MA ray intersects the circle at the 2 points AB. And in this rule, the tangent power to MC power 2 will be equals to, from the point M to the point of intersection of the chord, and from the point M to the end of the chord, which is AB. Here AB is a chord. So the tangent power 2, MC power 2, will be equals to MA multiplied by MB. Okay? Let's go to another slide and let's start solving examples. In the opposite figure, here in the opposite figure, AB chord intersection CD chord at the point H. So H is the point of intersection. And AH equals 3, HB equals 8. Here DC HD equals x minus 1 and CH equals x plus 1. Okay? So here we are going to solve this example together. The two chords intersect at the point H, so we will start from the point of intersection. HA multiplied by HB equals HD multiplied by HC. HA, its length equals 3 centimeter multiplied by HB 8 centimeter equals HD. Here HD equals x minus 1 multiplied by HC, which is x plus 1. 3 times 8 equals 24. X minus 1 multiplied by x plus 1, difference of two squares, which is equals to first times first minus second times second. So it will be x power of 2 minus 1. Negative 1 will go to the other side. So x power of 2 will be equals to 25. So x will be positive or negative the square root of 25, which is equals to 5. Okay, x equals positive or negative the square root of 25 equals positive or negative 5. Okay, here x can't be negative because x will be negative 5 minus 1, which is equals to negative 6, which is impossible. And here and in HC, if we put x equals negative 5, it will be negative 5 plus 1 equals negative 4, which is impossible because we don't have a negative length for a chord. So we will write x equal 5 and x equals negative 5 will be refused. Let's solve it again by using the PowerPoint. Solution. Okay, we don't have a written solution for the PowerPoint, and we solve it together and find the value of x. Okay, and here he wants to find the value of x, and we find the value of x, which is equals to 5. Let's go to another example. Here in the opposite figure, we are waiting for the figure. The figure, here is the figure. Okay, in the opposite figure, AB and CD are two chords. AB and CD are two chords. AB and CD are two chords intersect at the point H. This example will be a little difficult, so you have to give me your attention, please. Here we have AH equals 3 centimeter, HB equals 2 centimeter. But we don't know the length of HD and the length of HC. We don't know any one of them. But we know that the length of CD is equals to 5.5. the length of CD, all CD equals 5.5. Okay, so we can write that HD, its length will be x, and CH will be 5.5 minus x. Okay, again, here again, we know that CD, all the length of CD is 5.5. Okay, but we don't know the length of HD and the length of HC. So here we can write that the length of HD, will be x. So the length of HC will be 5.5 minus x. Okay, so if DC, its length equals 6, and DH will be x, so HC will be 6 minus x. Again, if CD, its length equals 10 centimeter, we will suppose that HD, its length will be x, so CH will be 10 minus x. And in this example, we know that CD equals 5.5, so we will let that HD equals x, and CH will be 5.5 minus x. Okay, here CH will be equals to x, so HD will be 5.5 minus x. Since AB or CD are two chords intersecting at H, so we know that HA multiplied by HB equals HD multiplied by HC. Okay, here HA times HB equals HC multiplied by HD. Here HA, its length is 3 centimeter, HB 2 centimeter. HC, its length is 5.5 minus x multiplied by HD, which is equals to x. Okay, let's multiply. 3 times 2, it will be 6. X times 5.5, it will be 5.5x. X multiplied by negative x, it will be negative x squared. Here you can multiply all the terms of the equation by 2, or you can multiply it by 10, or you can just arrange it. So you can write it as here, negative x go to the other side, it will be x power of 2. 5.5 will go to the other side, negative 5.5x plus 6 equal 0. And you can use your calculator by using mod 5 3 and put x square, the coefficient of x square is 1, the coefficient of x is negative 5.5, the coefficient of the free term is 5. So by using your calculator, you will find that x equals 3 over 2, which is 1.5, or x equal 4. Okay? But from the geometry of the figure, you can notice that HD is smaller than HC. So we will know that CH is the larger part of CD. So CH will be 4 centimeter and HD will be 1.5 centimeter. Because if CH is 4, so HD will be 5.5 minus 4, which is equals to 1.5. But we can't say that HD equals 4 centimeter and the CH equals 1.5, because the geometric shape, this shape, tells us that HD is smaller than HC. Okay? This is a tough example. You have to solve it again by yourself. Another example, in the opposite figure, here HB ray intersect CD ray at the point H. HB equals 2 centimeter, AB equals 7. If HD equals HD over HC equals 1 over 2, find the length of HC. Here is the figure. Okay. Here we have two chords CD and AB. This is the chord CD and this is the other chord AB. Okay, the two chords intersect at the point H and H lies outside the circle. This is the well known, this is the first case. The first case was if the two chords intersect inside the circle. The second case that the two chords intersect outside the circle. So this is the second case. And here we know that if the two chords intersect outside the circle, so the answer will be from H to the start point of the chord HD multiplied by HC equals H to the start of the chord, which is HB, multiplied by H to the end of the chord, which is HA. So HD multiplied by HC equals HB multiplied by HA. Okay, now you have HB equals 2 and HA, here HA will be 2 plus 7, this will be equals to 9. But here we don't have the length of HD or the length of DC, but we have a given rule. Here this is a given that HD over HC equal half. This is a ratio form, so we can write that HD, its length will be equals to K, 1K, and HC will be equals, here HC corresponds to, so we can write that HC, its length will be equals to K. Okay, so we can write HD, its length equals K multiplied by 2K. K multiplied by 2K, it will be 2K squared. 2 multiplied by 18, it will be equals to 18. 2 multiplied by 9 equals 18. Divided by 2, so K power of 2 will be equals to 9. So K will be equals to positive or negative 3. Okay, but here K is the length of the chord. This is the length of the chord. So K will be equals to 3 and K equal negative 3 will be refused. Okay, as you can see in the PowerPoint that K power of 2 equals 9. So K equals 3 or K equals negative 3, which is refused. So now here we want to find the length of HC. The length of HC, here we have that K HD, its length is equals to K, and CD HC, here its length equals to K. And we have K equals 3, so the length of HD will be equals to 3 centimeter and HC will be equals to 2K, so HC will be 2 multiplied by 3, which is equals to 6 centimeter. So HC will be equals to 6 centimeter. Okay, let's go to another example. As I told you, this is a very easy lesson in geometry. Here Y X-ray intersects ZL ray at the point M, where MX equals 4, ML equals 5, and LZ equals 7. Find the length of XY. Okay, here this problem we are going to solve it together. The two chords intersect outside the circle, so we will write ML multiplied by MZ. ML multiplied by MZ equals to MX multiplied by MY. This is equals to MX multiplied by MY. Okay, ML equals 5 multiplied by MZ. Here MZ equals 5 plus 7, which is equals to 12, and equals MX 4 centimeter multiplied by MY. Here we don't know the length of MY, so we will write it as it is, MY. 5 times 12 equals 60. 4 multiplied by my, it will be 4 my divided by 4. So my will be equals to 15 centimeter. My equals 15, but we want to find the length of xy. So xy will be equals to 15 centimeter minus 4 centimeter, which is equals to 11 centimeter. So xy will be equals to 11 centimeter. Okay, let's go to another example. Example 5. In the opposite figure, AD is a secant to the circle at C and D. AB is a tangent to the circle at B. Find the length of CD. Okay, this is the third case because here AB is a tangent. AB is a tangent. Okay, if AB is a tangent, so what is the rule? AB is a tangent means AB power of 2 equals, this is the tangent power 2 equals from the A to C multiplied by A times B. So AB power 2 will be equals to AC multiplied by AD. Okay, so AB 6 power of 2 equals AC 4 multiplied by AD. Here we don't know the length of AD, so we will write AD. 6 power of 2, 36 equals 4 multiplied by AD divided by 4. So AD will be equals to 9 centimeter. But we want to find the length of CD. We know that AD equals 9 centimeter, so CD will be equals to 9 minus 4, which is equals to 5 centimeter. Okay? Okay, let's go to another example. Example 6. M is a point outside the circle where MA is a secant, intersect it at A and B, where MA bigger than MB. MC equals 10, AB equals 15. Find the length of MB. We are waiting to the figure to appear. Here is the figure. Okay, so let's go to solve. Let's solve this problem together. Here you can see that MC is a point outside the circle, MA is a secant. Here MA is a secant means that MA intersects the circle at 2 points, A and B, where MA is bigger than MB. MA is bigger than MB. If MC equals 10 centimeter, find the length of MB. Here you can see that MC touches the circle at C, so MC is a tangent. So we can write MC power of 2, MC power of 2 equals MB multiplied by MA. MC equals 10, so 10 power 2 equals MB. Here we don't know the length of MB. So we can suppose that MB, its length will be equals to x centimeter. So MB will be x. And what about MA? MA here, MA equals x plus 15. Okay? If we suppose that MB, its length equals x, so the length of MA will be MB plus BA. MB equals x and BA equals 15. So MA will be equals to x plus 15. Okay? Don't say that the length of MA will be equals to 15x. This is a wrong statement. Okay? Here MA equals MB plus BA. MB equals x, and BA, its length equals 15, so MA equals x plus 15. 10 power of 2, it will be 100. We are going to distribute x times x, x power of 2, x times 15 equals 15x. Put it in the form of the quadratic equation, x power of 2 plus 15x minus 100 equals 0. Then by using your calculator mode 5-3, here you can find that x equal 5 or x equals negative 20. X equal negative 20 is refused because MB, x is the length of MB, so MB equals 5 centimeter. Okay, let's go to another example. Okay, let's start another idea. Converse of well-known problem. The converse of the well-known problem. Okay, if the line containing the two segments AB and CD intersect at the point E, A, B, C and D and also E are distinct point. Distinct means different points, and EA times EB equals EC times ED. So the point A, B, C and D lie on a circle. Okay, I will explain it to you right now by using the opposite figure. Okay, give me your attention please. Here we have two chords intersects in a circle. Here we have two chords intersect inside the circle at the point E. If it is given to you, that AE multiplied by EB equals to CE multiplied by ED. So first we are going to find AE multiplied by EB, and we are going to find CE multiplied by ED. If the two sides are equal to each other, okay, then we can say that the points A, D, B and C, all of them lie on a circle. So if A, D, B and C lie on a circle, you can say that AD, B, C, or the figure ADBE is a cyclic quadrilateral. So the vertices is A, D, B, C, okay, lies on the circle. Here the repeated letter is E, so you will cancel E. Here the repeated letter is E, so you can say that A, B, C and D lies on one circle, which means that the figure ADBC is a cyclic quadrilateral. By the same way, if you find in the second figure that if ED multiplied by EC, so first you are going to find ED multiplied by EC and you will find the answer. Then you are going to multiply EB, are going to find the result of multiplying EB by EA, EB by EA. If the two results are equal to each other, then you can say that the points D, C, A and B, all of them lie on one circle, which means that the figure C, A, B, D, this figure here is a cyclic quadrilateral. So you can say that the figure ABDC or ACDB is a cyclic quadrilateral. So this is another way to prove that the figure ABDC is a cyclic quadrilateral by using the two intersecting chords inside the circle or the two intersecting chords outside the circle. Okay, let's take an example to explain this rule. Example 7. Here ABC is a triangle in which AC equals 9, BC equals 12. Let D belongs to AC, where AD equal 5 centimeter. Let E belongs to BC, where BE over EC equals 3. Prove that the figure ABED is a cyclic quadrilateral. Okay? Here we want to prove that the figure ABED is a cyclic quadrilateral. We want to prove that this figure is a cyclic quadrilateral. Okay? So to prove that ABED is a cyclic quadrilateral, here the two chords AD and BE intersect at the point C. If you want to prove that ABED is a cyclic quadrilateral, you can imagine that there is a circle passes through the vertices of A, B, E, and D. So AD will be a chord in this circle, and BE is also will be a chord in this circle. The two chords will intersect at the point C. So we are going to find CD multiplied by CA, and we are going to find CE multiplied by CB, and if the two results equals to each other, so you can say that the figure EDAB is a cyclic quadrilateral. But here we don't know the length of CD, but we know that CA equals 9 centimeters. Here is a given ratio to you. Here we have that BE, here BE over EC equals 3 over 1. Okay? Okay, so if we multiply, so 3 EC equals 1 BE. Cross multiplication, so here 3 EC equals 1 BE. Okay, but we know that CB here, the length of CB equals 12 centimeter. Here again the length of CB equals 12 centimeter, and the length of BE equal 3 the length of EC. We can write that BE equal 3 EC. If we suppose that the length of EC is x centimeter, so BE will be equals to 3x. So we can write that BE equals 3x, and CE, its length, will be equals to x. Now we know that BC will be 4x equals 12. So now the length of BE, we know that the length of BC equals 12 centimeter, and the ratio of BC equals 4x. So 4x equals 12, which means that x equals 3. So now we know that CE, its length, will be equals to 3, and BE, its length, will be equals to 3 times 3, which is equals to 9 centimeter. Okay? Okay. And here AC equals 9 centimeter. We know that AC here, AC equals 9 centimeter, and AD equals 5 centimeter. So CD will be 4 centimeter. Okay? Let's substitute in the given equation. CD here, now we know all the lengths of any side. Here CD equals 4 multiplied by CA, which is equals to 9 centimeter, so the result will be 36 centimeter. CE multiplied by CB, CE equals 3 centimeter multiplied by CB, which is equals to 9 centimeter. Here for x equals 12, so x equals 3. So CB, here CE, its length will be equals to 3, and EB equals to 9 centimeter. Here CB is equals to 12 centimeter, so it will be here, sorry, I will erase it again. Here the length of CE is 3 centimeter and the length of CB is 12 centimeter, so the result will be 36. So from 1 and 2 you have that CD multiplied by CA equals CE multiplied by CB. Here from this equation you can say that cancel the repeated letter here, so A, D, E and B, all of them lies on one circle, they lie on one circle, so ABED is a cyclic quadrilateral. Let's solve it again together by using the PowerPoint. Okay, solution. First, CD is 9 centimeter. Here we have AC equals 9 centimeter, so CD will be 9 minus 5, so it will be equals to 4 centimeter. Here CD times CA equals CD times CA equals 4 times 9 equals 36. Here this is the tricky part in this example. BE equal 3 EC, cross multiplication, so BE equals 3 CE. So BC equals 4 CE, but we know that BC equals 12 centimeter, so BC will be equals to 12 equals 4 CE, so CE will be equals to 3 centimeter, and EB will be equals to 9 centimeter. CE times CB equals 3 times 12 equals 36. So from 1 here, from the first equation, we know that here CD times CA equals 36, and from the other part we know that CE times CB equals 36. So now you have CD times CA equals CE times CB. So now you know that here the figure ABED is a cyclic quadrilateral. Last example, corollary 2, and the last example. Again, here if you find that EA power 2 equals to EB multiplied by EC, okay, if you find that EA for all power of 2 equals EB multiplied by EC, okay, then EA is a tangent to the segment, so EA is a tangent segment to the circle which passes through the points A, B and C, okay. So if you can prove that EA power of 2 equals EB multiplied by EC, so you can say that EA is a tangent segment to the circle passes through the points A, B and C, okay. Let's take an example. In the opposite figure, here ABC is a right angle triangle at B. AB equals 4 centimeter, CD equals 1.8 centimeter. Proves that here BC is a tangent. We need to prove that BC is a tangent to the circle passing through the points A, B and D, okay. Here we want to prove that BC here is a tangent to the circle passing through the 3 points A, B, and D. So we will let that there is a circle passes through here the points A, D, and B. And we want to prove that CA here is CB is a tangent. Here we will find CB power of 2. CB power of 2 will be equals to 3 power of 2, which is equals to 9. And from Pythagoras theorem, we have CB equals 3 centimeter and AB equals 4 centimeter. So AC will be the square root of 3 power of 2 plus 4 power of 2. So this is equals to 5 centimeter. So to find the length of AD, AD will be equals to 5 minus 1.8, which is equals to 3.2 centimeter. Okay? So CB power 2 will be equals to 3 power 2 equals 9, and we will find CD multiplied by CA. CD multiplied by CA. CD, which is equals to 1.8 multiplied by CA, which is equals to 5 centimeter. Okay? 1.8 multiplied by 5, it will be equals to 9. Now you have that CB square equals CD multiplied by CA. So since CB square equals CD by CA, cancel the repeated letter. Okay? So you can say that CB is a tangent to the circle which passes through the vertices of the triangle A, B, and D. Okay, thank you so much. Until we meet again next time, goodbye and good luck.